As a general purpose language, Kotlin touches our lives everywhere. When you're paying your taxes, the servers processing those documents might be running Kotlin. When you're watching a movie on an airplane, that system is probably running Kotlin. And as we will see today, even on your commute in some of the greatest cities in the world, you've got touch points with Kotlin, quite literally. And not just any flavor of Kotlin, Kotlin Multiplatform, and beyond just phones. Today, we're sitting down with Paweł Kwieciński from Masabi to talk about how Kotlin is used in ticketing for public transportation. This is Talking Kotlin. I'm your host, Sebastian Eichner, and I'm joined by my lovely co host, Marton Braun. All right. Hey, Paweł, welcome to the show. Good to have you here.
Hey, thanks for having me.
So I'm really, really excited about today's episode. But I just want you to have the opportunity to set the scene here a little bit. Could you tell us a little bit about what Masabi is and what it is that you folks do?
Sure. So Masabi is we brand ourselves as a mobility as a service solution for public transport. So think of public transport agencies. We operate across continents. Some large cities like MTA in New York could be, I think it's the biggest customer. And then there's a couple more customers in the US, also some in Europe. There's one in Spain, for example. So the customer base is growing, so we're expanding globally. Mobility as a service is essentially an end-to-end solution if you run a public transport agency. So think of ticketing, analytics, gates, validators on buses, mobile apps for bus drivers. There's even some ferry companies that operate using this product. So it's pretty flexible in terms of what's supported.
So when someone is running on these products, basically every screen involved in showing anything about transportation in that city is powered by your solutions, essentially, right? So
It could be like this if these agencies like opt in for the full end-to-end integration, but there are some customers which have some existing systems or some proprietary software that we integrate into using our SDKs. So it might be a mix of both. It depends. Again, it's pretty flexible in terms of how you want to integrate or how you want to adopt this solution.
Now, of course, the question is, how does Kotlin fit into this story? That is what we're doing on this podcast here.
Yeah, exactly. That's why you're here. So I joined over 2 years ago, Masabi, and already then there was this transition ongoing from Java, pretty old Java, to modern Kotlin, especially on the backend side, because there's a lot of backend software running as well, as you can imagine, not just mobile apps and all that. And for me personally, I'm in a team called validation. So think of ticket validation. So everything related around that. So we have SDKs that run on embedded devices using Java, and we have mobile apps that expose a front end using that SDK. So it all builds on top of that layer by layer. And that's also when we decided that this pretty old code base with Java 1.7 it needs an upgrade. So it was pretty ancient code, and yeah, going with the whole theme of modernizing and also unifying the language that we're going to use at Masabi. So both for the backend, which already started on Kotlin, and also for this part, we also want to go with Kotlin. And this project for the validation side, as I mentioned, there's a majority of it is an SDK that we ship for JVM and Android. So if, for instance, you have already a existing app for ticket validation, you can integrate the SDK. But if not, we can provide a whole front end, so the whole Android app as well that builds on top of that SDK. Additionally, there's a iOS client, as in an iOS app that runs this. So back when I joined, that was all built using Java. And with this unique, for me, I was unique at that time, was using Objective-C for the iOS part. So we were translating Java code into Objective-C and then built UI natively for iOS on top of that. Also, something that was really, I think, ahead of its time in that code base is that the view models were already shared thanks to Objective-C. So you would have view models written in Java, and they would run on both Android and iOS through the means of Objective-C. So that was pretty cool. So there's already some groundwork to modernize it. Like already the view models were reusable. So just a matter of, pretty much translate it to Kotlin, do some adoption. Of course, we will get into details about that if you want. But it sounds simple, but it's a fairly large code base. So there's a lot of business logic. Ticket validation, yeah, there's a bunch of rules and stuff and many different use cases and many different systems you expose. And the SDK is also pretty flexible for what you can do with it. So
Yeah.
yeah.
I mean, I can't wait to dive deeper into like a lot of these subjects. First of all, though, I'm just very excited that there are efforts going on in many places to do some modernization. I can show you what the ticketing system looks like here in Munich. For our audio listeners, you will have to go with the audio description. This is a single ticket for a single ride in Munich. It is a paper sheet that you put into a machine that applies a stamp on it. And we're just gonna ignore the fact that also a single ticket is €4.10, which is crazy to me. But yeah, whenever I go to another place and I get the tap to pay terminals on the ticket gates and so on, I always feel like I travel a tiny bit into the future. Though maybe it's more that I'm traveling into the past when I'm coming home to Munich. I'm not really sure. Yeah.
Yeah, I think we should say that we are pretty big fans of transport here. Obviously, visiting conferences and such, we do have like our own little collection of travel cars and such from all over the place. But the nicest time is definitely when you don't need to deal with a travel card and you don't need to download an app and you can just tap through.
Yeah, something I can mention here that I didn't say it before, but we also offer, as Masabi as a platform also offers EMV payments. That is, you can tap your payment card to go in and out of a gate and a subway. But that's of course for the customer to decide if they want to implement it, if they want to roll it out and support in their public transport system.
Okay, so I think we covered a bunch of components of how the system fits together. So there's obviously a lot of things on the back end, as you mentioned. Then there is the mobile SDK, which again has that like interesting shared view model thing, which I think we should dive into. And then there's also the software on the gates, right? Which is another piece. And you said it's embedded Java.
Yeah, there's a. I'll try to map it out maybe in more detail, then it makes more sense. As you mentioned, there's a couple of end devices you can run this on. Mobile devices are one of them, so iOS and Android, but also any proprietary board that can run Java, we can deploy the embedded SDK, which is part of this system, the validation system. And then that code for the SDK, which is Java, well, now it's Kotlin after the whole transition. We also use it as the base for the mobile SDKs. So currently on the Android, iOS is on the way, which also related to what we're doing with the rewrite to enable a easier rollout of the iOS SDK without going into Objective-C if we don't have to, for reasons. And on top of that, we built mobile apps, so iOS and Android. So you can
everything
choose
that's-
you can choose which part you want to consume when you're integrating the system. If you already have a bunch of iOS devices, you would probably go for the iOS app and just deploy that to your bus drivers or whatever you have, validators or inspectors, we call them, and use that. Similarly, if you have existing gates that run, usually they run some form of Linux, so usually they can run Java, which means you can deploy the embedded SDK.
I'm kind of curious here because you said maybe the validators are running iOS. What might that look like? Like, do I imagine just someone like walking through a train with a tablet, or?
Yeah, that's precisely what it is. I think we have one customer that's using iOS iPads, but most of the time it's just iPhone devices.
where
So
do people
literally,
have
yeah,
to
like
go
a
to
ticket
try that?
inspector, go through the train and literally scan. Usually it's QR codes. The tickets are QR codes. So the app has a embedded camera scanner, and you just point it at the QR code. We read it, and then that's how you validate the ticket.
Very cool. I'm really excited specifically about the fact that the ticket gates can also run Kotlin, because I mean, with the entire mobile story of Kotlin multi-platform being in the forefront a lot of the time, it's once again like it illustrates the fact that having the JVM as a target means that wherever you can run JVM code, you can also bring your Kotlin multi-platform code. I'm curious, is there because I guess there is also like ticketing machines not on the validation side, but like the tickets also need to be created and like printed and
Exactly.
stuff. Is that also part of the stack?
Yes, not the validation part, but I could talk about it. Also, one more note on the hardware validators, because we mentioned gates, but also what we do is we provide also devices. If the agency doesn't have existing hardware, we provide these devices which run Linux, or now we also experimenting with devices that run Android. So if you go on a bus, you see these screens like at the pole. So these are these things where you just tap your card or whatever. So these also run the embedded SDK, the Java one that I mentioned. But circling back to your question, you mentioned tickets and they need to be generated. Yes. Well, talking about single-use tickets, that's correct. You would generate them on the backend side, and there you get a QR code essentially, which is just a string of characters that the app knows or the SDK knows, because that logic lives in the SDK, knows how to decode. And there's a bunch of different ticket formats that we support, and that again all exists in the shared SDK.
So with a bunch of these embedded parts which are running JVM, you said you can basically run it on any board that can run a JVM. So what's the like minimum viable hardware that you can put in there? I'm thinking like a base spec Raspberry Pi sort of computer here. And does that give you any limitations in what you can do in your code in terms of memory or anything?
I probably don't know from the top of my head any requirements per se. I think we do have like a spec that's the minimum supported things, but just going from the top of my head, in terms of like raw processing, that isn't much needed. Also, I think for RAM, not so much. Maybe for storage, you would want something reasonable, as in, because some of these validators, they need to work offline, and the way they do that, they synchronize the database with the backend.
Yeah, this would have been my next question, like whether this requires a network or no.
Because what I mentioned before, we talked about mostly focused on single-use tickets, but that's just one way of ticketing. You showed the cards before, and that's also something we support. So we call it account-based ticketing. So you would have some form of identifier like a card, and that links to your account. So then that state of that account needs to be synchronized somewhere, somehow, and that's what's being done on the validators as well. So they can validate your card even if they're offline.
Okay. I mean, maybe we're reaching too much into trade secret territory
Oh
here,
yeah.
but is
Yeah.
there
Yeah.
like is there really just like is my card really just an identifier, or like does it actually store any? Because I think with the IC cards that like they're supposed to do some sort of like cryptography perhaps or something like that.
Yeah. Again, it depends. There are many different cards. I mentioned yeah, well, we can get into the weeds here
Yeah.
a bit, because I mentioned EMV, which is essentially MasterCard or a Visa, and then you're tied to the payment provider and everything has to go through that. But you also have proprietary cards, which are just just some form of identifier. I don't know exactly how they work. I know there's some cryptography involved, so there's some keys that need to be decrypted to read it, and those are also stored on the backend side, and then there's some exchange to be able to decrypt those.
Okay. All right, then I'm gonna ask it. So, sorry, I thought Marton had something on this, but I guess not. So I want to dive a little bit deeper into the actual KMP story and how this connects to things, because obviously I think by now the story is quite a traditional one. If you already have an existing Java code base and you need to add multi-platform capabilities, well, Kotlin multi-platform is a great thing. You'll still have to do a little bit of work, but it's definitely a doable thing. You're in a slightly you were in a slightly different position though, in the sense that you already had a solution that that allowed you to do multi-platform using Java, using J2 Objective-C. And you're also not the only ones. Google, for example, was historically also building a bunch of their mobile apps using J2 Objective-C before moving to Kotlin multi-platform eventually. So I was just very curious, like, what was the experience with J2 Objective-C? Why did you decide to move to Kotlin multi-platform? These kind of things.
Yeah, it's good that you mentioned Google. We have to give credit where credit's due, because J2C, if I'm not mistaken, that was created by Google.
Yep.
I think the original purpose was for Google Docs, if I'm not mistaken, to use it there. Yeah, well, I think the core aspect to answer this is that this started over 10 years ago. So we didn't really have a choice, especially not Kotlin and Kotlin multi-platform back then. There could have been, I don't know, I'm probably 13 years now started as an Android developer. And I think when I started, there were things like PhoneGap, for example. I'm not sure if you're aware of that one.
Yes.
Which were very far from perfect, having experimented with it a bit. And also, so there's that, the availability of solutions, but also the fact that this code base is very heavy on business logic, not that much UI. So there wasn't strictly a requirement to have like a cross-platform solution that's solely focused on mobile apps or UI. Again, we also support the embedded aspect. So this was the most flexible at that time. Again, I'm just partially guessing, but partially making sense of what I've seen, because again, that decision happened probably like 10 years ago. And Data Objective-C has its benefits. I think it's pretty impressive in terms of what it's capable to do. And also, once integrated, I think it's pretty seamless to work with it. And yeah, but I think the thing that drove the decision to move away was that, first of all, when you look at that repository and the documentation, you see there's not much going on. So we were fearing to run into this situation where we probably want to move up with the Java version, and that's no longer supported by Objective-C, and then you're locked in because you cannot do anything. You would first need to do this huge migration to get away from Objective-C and to be able to upgrade Java. So we didn't want to have to deal with that in the future. That was why we decided. Also, I mentioned the iOS SDK before, and something that we want to ship in the near future. The work is ongoing. And to make that easier, and by easier, I mean probably not dealing with Objective-C code too much if we don't have to, or rewrite parts of the embedded and resulting in then some duplication. We also want to avoid that. So ultimately decided these are the two main reasons we would like to move on.
You mentioned that it's mostly business logic that you had in your SDK, which I assume would be a good fit for something like J2 Objective-C, because things like creating classes and doing math and passing values around and evaluating things, I assume that would be the parts of the code that are easy to translate. But I assume there's also certain limitations in J2 Objective-C and what APIs you can call. Like I guess you must have strings and kind of built-in things like that, but maybe something like an input stream or networking call is more difficult.
Actually, that was my thought in the beginning when I first seen this. There's probably tons of workarounds to get things working with I/O, like you mentioned I/O, but I was pleasantly surprised that actually very flexible and very feature complete in terms of what it supports. That's available in Java, and again, that's limited to I think Java 11 at this point, which makes sense. It was kept being up to date, and then kind of once Java moved on at a much faster rate recently, that these features are of course not supported anymore. I think up to Java 11, as I mentioned. So you do get the language level features, but also most importantly, the Objective-C provides support for the common dependencies, like the org.json package that's supported. There's I don't know from the top. There's a bunch more. I think Apache Commons also is in there. I think JSON as well available. So you can build a lot with just that.
Okay. I mean, I think for its time, it was quite a good solution, and I mean, it seems like a miracle being able to take a language like Java that runs on the JVM and being able to ahead of time compile that into Objective-C of all languages. But I guess there's still some benefits that we have on the Kotlin multi-platform side. I'm recalling here the kind of story when we were talking to the Google Workspace team. So that's the team building, Google Docs, Slides, Calendar, whatever. When they were evaluating the original move from J2 Objective-C to Kotlin, they thought they did something wrong because they observed such huge performance boosts in actual execution speed. As I recall, it was double-digit performance improvements. So they weren't really sure whether they had measured wrong, but it turned out that besides, of course, the improved null safety thanks to Kotlin, you're also getting you're also getting a little bit more speed thanks to the Kotlin multi-platform, runtime garbage collector, or just not the overhead of going through Objective-C in this classic sense. This is also something that the team from Google Workspace has talked about. We can probably link the KotlinConf talk on this in the show notes as well if you want to check this out. I think there might be even two of them, one from the beginning of the migration and one with the lessons learned afterwards.
I
which is
think
quite
we
exciting.
might be up to 3 talks now.
Oh, up to 3 already. Look at that.
I
There's
think it's
so
a
much.
yearly update from Workspace.
There's so many good materials. I mean, it's also quite a magnificent case study in and of itself. Did you evaluate any other technologies when you were thinking about the move away from J to Objective C?
Probably no, because as I mentioned, the company was already aligned on Kotlin as the best solution for the backend to move to. So that was a major argument to not divert from that. Also, the fact that we had this JVM requirement that this stuff needs to work on the JVM. So these two alone pretty much shift the favor towards that. Also, the whole language adoption thing. Like, if people are familiar with Java, can work with Java, it's easy to get them across to Kotlin, and many will happily jump from Java to Kotlin, including myself. So yeah, it was pretty simple. But if you want to talk about the multi-platform part itself, because yeah, when I joined Masabi, I already had some exposure to multi-platform from some previous companies, also having experimented myself, and prior to that, also having comparison with technologies like PhoneGap and some other ancient tools. You could immediately see that this is something else and something probably a tier up, and it's a flexible solution, as in you can have the pick and choose the platforms you want to support and so on. So we did some internal discussions, evaluations, like line out the pros and the cons, and after that was a pretty simple decision to move forward.
I think it's kind of cool having a story that actually doesn't begin with the mobile part, but that begins with the server side story and then extends out to the other platforms. It makes perfect sense the way you describe it. If you're happy with it on one platform, it makes sense to roll it out to others rather than like keep fragmenting it. And it does come, of course, with the benefits of, well, you get to write Kotlin and you get to hire people who like writing Kotlin, all these kind of things. This is really like that part is really neat. So the decision was made. You wanted to move to Kotlin multi-platform. What happened next?
Good question. Planning, extensive planning, pretty much. Probably need to explain the code base a bit, because that's like I mentioned, there's the subsystems and the artifacts that already brought up. So the mobile apps and the embedded SDK being the main ones. It all existed in a monorepo, which is, there's probably split opinions about monorepos, but probably in favor in terms of this adoption. So also a characteristic of this code base, what it was, that it wasn't heavily modularized. Like, it was pretty much, I think, just modules for the iOS app, Android app, the embedded SDK, and then like a core module, maybe like 2 helper modules.
Just a big
ball. So that was, just a big ball of things, which you eventually probably get if you don't pay attention, like after 15 years of development. The good thing, though, to balance it out with the good with the bad, was that there was quite a bit of good tests that we could definitely leverage in terms of migration. I can talk about it more. We can talk about it more later, because testing was an important aspect of this whole migration. So we kind of needed to, and that's important before I continue. The major requirement that we agreed on in this migration was that we want to do it incrementally. Like, we don't want to lose any flexibility in terms of releasing and adding new features while the migration is ongoing. And that brings me back to the fact that it was just a big ball of things. So like some huge modules with 20, 30 plus K lines of code. So we quickly arrived at the conclusion that the first thing to do is to split things up, modularize this code base. Especially when we looked at closer at the code. It was immediately obvious that there's some subsystems that you can mostly move out and create like a proper hierarchy of modules. And yeah, it has many benefits, like organizing code and then having piecemeal things you can migrate, but also in terms of Gradle, it gives you benefits for build speed and caching. So that's another benefit you get with this. So it was a pretty easy decision to do it as the first part of this whole effort. So even before touching any Java code, moving it to Kotlin, that was the first step.
Yeah, and of course the incremental migration is something that from the very beginning of Kotlin was really important for the language, especially that JVM interop use case, which I guess also makes it that much of an easier choice because you don't need to rewrite all at once. You can split out different parts. You can figure out which part you want to convert to Kotlin first, and you really can do it step by step.
Exactly.
Versus doing like a rewrite in JavaScript or something, or like whatever other language or technology you would want to migrate to. Here you get to do it step by step, which is quite nice. I should also mention that KMP in general works pretty well with monorepos. So from that standpoint, you were also set up nicely because we do support all the different scenarios of having your like mobile apps, for example, in different repos and such. But I think it's still the easiest time if you have everything in the same monorepo, just in terms of managing your code and connecting the KMP bit with other parts.
I think
and I think we can.
I think this part is not. I hate lag.
Raise your hand.
Yeah, just
we're leaving that in.
Just go ahead.
And I think we can probably stop drawing parallels with Google here, but of course, all of their code is also in a monorepo as they performed a similar migration there. Seb, go ahead.
Yeah, I think this part isn't even like particularly exclusive to Kotlin Multiplatform, because I think it's just more and more people coming around to the fact that if you have a bunch of things that are interconnected and that are expecting the interfaces to be in a certain shape or that are expecting certain things to behave in a specific way, if you have an ability to kind of do a global-ish snapshot of the system at any given time, it's a lot easier if that history is like a unified one rather than like three Git repos in a trench coat, I guess. So we're in the middle of, we figured out that we want to move to Kotlin Multiplatform. We've planned out a split into potentially more modules, specifically more Gradle modules. Were you already using Gradle before?
Yeah. In this repository, yes. There's some helper libraries where we still had Maven, but that was minor comparison to this. That was already on Gradle. Yeah.
So then, where did the first lines of Kotlin land? Did you do the classic move of writing some tests? Did you just move some data classes over?
I think like the first step was just a POC, adding a new POC module to the repository, and just see if we can easily add the dependencies for the KMP plugin and whatever else is required, and that it builds and runs alongside J2Objective-C, because that's, again, J2Objective-C has to remain, of course, while you're doing the incremental migration. So we just wanted to try if there's no like unforeseen, unexpected things like getting conflicting with each other. So that was literally the first step. And then after that, again, I briefly mentioned the helper libraries. So there's a bunch of smaller scope repositories that we use for example, there's some things around some specific ticket format that has a decoder and encoder for that. So that existed as a separate repository, because that's also, as you can probably expect, it's used by the backend to like encode these tickets. So that didn't exist in this repository, existed in a separate repository. And that was also using Java. That didn't have the JIT Objective-C part, but because that, of course, was a standalone thing. So we started with those. And the benefit of that is that these are fairly small code bases. So it's a good place to start. Also, they don't touch the existing products, like, because they're versioned and they're published as artifacts, so it's very safe. You can do it extremely safely. You just publish a different version, a different major version, then you can decide to adopt once you think it's ready. So we have started with that. There was probably 10 of those. And another benefit of that is that was a good way to get people on board with Kotlin Multiplatform, to have a very small set of code and rather simple things to get them familiar with the technology. Instead of just throwing them into the deep water with a big huge monorepo, and that probably wouldn't be a good approach. And yeah, these served as then good examples, and migrating those served as good blueprints for the future things that we're going to do. So these were the initial steps that we did, and we discovered a lot of patterns that we can then repeat across the different repositories, and ultimately apply those migration patterns also in the big repository. Like, for example, how you want to set up the CI build, that it runs on both the iOS and then embedded, and then it runs the tests also on the iOS target and the JVM target and the Android target, things like that.
That's really cool. So of course, in the migration, actually, maybe this is a curious question, because I feel like in my mind I've maybe been conflating a couple of things a little bit here, because we've been talking about J2 Objective-C, and the J stands for Java, so it stands to reason that not all of the code that you had was originally Kotlin when you started moving this. It's not just switching out the compiler and moving things into a different file. There was, I assume, also a step involved of actually rewriting some Java code into Kotlin.
Not sure I got what you're saying here. The libraries I mentioned, they were in Java, yes, and the first step was to rewrite them in Kotlin, and then make the necessary adjustments to make that Kotlin JVM code multi-platform code. So like a two-step process. Well,
Okay.
more steps, because then we can talk about how we use tests to then validate these migrations, because that was, again, something we experimented on the small libraries to arrive at a process that we can then extrapolate and apply to the other things that we're going to migrate.
I want to hear more about that right away. I'm not even gonna postpone this. So, because I'm very curious about how you approach this. It kind of makes sense in the sense that you have an existing implementation that has certain behaviors, and then you're rewriting it in a different language, and you probably want to make sure that the new thing has the same behaviors, right? Is that the core part? Very curious how you approach this.
Yeah, we were in the good situation where these things were fairly well tested. So initially you had the production code in Java and the tests in Java. And then first step would be to move the production code from Java to Kotlin. But then how do you know you did it correctly? I mean, you can, of course, run the automatic translation. Again, something we can talk about later that is extremely, extremely exciting. And I think we should reserve some time for that, is how you do the actual translation, because that evolved a lot through the last 2 years. When we started, it changed dramatically. But I digress, we get back to it. So you would move the production code to Kotlin, but then you need to validate if it's actually correct. Like so we had the tests in Java, so we would keep the tests, not migrate all the tests and the production code at the same time, because then you have this problem where you could introduce bugs in the tests or in the production code, and you wouldn't know if there's a bug at all, because you've made some changes in the test and now it passes because you made some behavioral change or not. So the process was to move the production code itself first, and then make the tests in their current form run against this Kotlin migrated code. And only then, when you know the tests are working and they're green, that your migration is probably correct, probably meaning that there's probably not 100% coverage of all the branches, but it still was pretty good coverage and good enough for us to say, this is probably good, we can continue with that. And only then we would move the test code to Kotlin after that was completed.
So,
Which again, there's some more things about tests I would like to talk about later, probably.
Well, we'll save some time for that for sure.
Okay.
So it sounds like all of these tests have been built and executed on the JVM
Exactly.
so far. But once you have migrated both your production code and your test code to Kotlin, that also unlocks running them in the native environment.
Yes.
I don't know if you were able to do that before. Like with your previous multi-platform setup with J2 Objective-C, did you only ever test on Java and then trust that J2 Objective-C converts everything perfectly? Or how did that work? And are you running your tests on multiple platforms now that they're in Kotlin?
Yeah, excellent question. For the lower layer parts, like the libraries I mentioned, no, because they're built standalone as a JVM artifact, so there's no J2 Objective-C involved there, we cannot use it. But for the stuff that's in the monorepo that we have, where we have J2 Objective-C, where we're using that to compile the Java for iOS use, we were also doing that for tests, and we would have some tests were just translated directly, and then they would result in J2 Objective-C test code that we could run under iOS. But also we had modules which were test contracts, which were plain Java code that we would then also use in the whole J2 Objective-C pipeline to translate these test contracts to iOS and then implement these test contracts on the native side to be able to test either some business logic or exercise some subsystem directly on the native platform.
That's fascinating. The more I hear about this, the more it feels like these technologies in some sense are very similar. You're just upgrading to a newer, like much more modern and more supported version of a similar setup. Like obviously there are technical differences here, like transpiling versus compiling and so on. But it feels like a lot of the possibilities and features that you have are actually quite similar, which is fascinating, and it might make for like a very natural migration for a lot of people.
Yeah, I agree. And well, you could say it's just a kind of a lower level approach. So you have the flexibility of implementing all these like shared code behaviors or shared tests. You just have to build your own layer on top of that to facilitate it. And for us, the way of doing that is having these test contracts, which then were implemented on the native platforms.
Sweet. So I want to actually now give you an opportunity to talk about this wonderfully broad subject of translating Java into the Kotlin that you ended up with. So what is the story there?
Oh yeah, I'm happy to talk about this because it's been quite a story, quite a journey. Like the translation part itself is what I want to probably focus on, like getting the actual Java code into Kotlin. because it started probably over 2 years ago now when we started with this migration. It can seem like a long time, but remember that we were doing an incremental migration. At the same time, we also doing the regular work for feature development and all that. So
And you were doing it in an existing code base that was growing already for a long time.
So yeah, like the usual anecdote is, or parallel, or is that you're changing the tire on the moving car. That's what we're doing. But the fascinating thing is how this translation itself evolved, and a big contributor to that is the recent developments with AI and how that's progressing. And as you know, that space is moving extremely fast, and that's what we've seen extremely well with this Kotlin translation. Because when we started 2 years ago, the best thing I think we had for doing it was the built-in IntelliJ, like convert from Java to Kotlin action. So we were starting with that, and we were using it a lot. And as you know, it's not perfect. It's it's okay. It's okay to start with, but as you'll see at the end of this story, it's now we're in a completely different world in terms of that. So we started with that, and there was a lot of manual work still required. For the more complex types and classes and files, it was frankly easier to do a manual rewrite instead of applying the automatic translation.
Mm-hmm.
I'm by no means complaining about it. It was still helpful, especially for some simple data types, was good. I wish it could handle Lombok. Then Lombok, we had to manually de-Lombok. Fortunately, we didn't use Lombok that much, so it wasn't that much of a pain. But also a challenge was nullability, handling that. Because in some cases, like in some of the more complex type hierarchies, it took a while to figure out what the proper nullability should be. Sometimes it wasn't even the one that was initially implemented in Java, because through the 10 years the code base evolved, and at some of the things changed to the point where probably some things that were nullable were no longer nullable, should probably no longer be nullable anymore. And Kotlin forced us to make that decision. So we had to spend some time to analyze the data flows and ultimately make a decision if we're going to make this nullable or not. Just some very specific example of that migration. But ultimately, we decided we initially want to make as most of a one-to-one migration as possible. The reason for that was to not introduce any bugs or any behavioral changes to the code. And only then, once we're happy with that, everything's migrated, only then we would go back and make so-called second pass. And that's where we apply the nice syntax triggers and so on from Kotlin, or maybe replace input streams with something more like or replace HTTP URL connection with Ktor. That's also what we did. But for the initial pass, we only focused on the language itself, not changing any libraries and so on. Of course, like I mentioned, HTTP URL connection, of course, you cannot get it across to common because that's the Java standard library. So you're kind of forced in some places you're forced to make the change. I think actually a better example of that is calendar or Java time, because there you need to make the change to go from Java to Kotlin Multiplatform. And the obvious choice there was to use Kotlin Next Date Time, but these APIs are not one-to-one. So there was a challenge there as well, like figuring out how to deal with certain APIs and patterns to like use the correct time zone, serialization or deserialization, and so on, and datetime formatter, how we're going to deal with that. So there was some decisions we couldn't postpone, and they would need to be made there and then. And the way to deal with that was to, again, an important strategy dealing with this migration was to write tests. So if there's an implementation that you need to change, for example, because you cannot use the standard library anymore, we would properly introduce Java tests for the Java code first and make these tests run against the existing code. And then once we're happy with the coverage, we would then apply the changes, move to Kotlin, move to Kotlin next date time in the case of calendar or Java time. And only then validate with the test we just wrote step before, and only then we would be sure that the migration was correct. I need a sip.
Please.
That sounds like a very measured and deliberate way of doing a migration. I think we heard this from a couple of migration stories now. Well, we also, I should mention that I think we already heard the word de-Lombok before, which I think is something a lot of people coming from legacy.
I think there's a plugin called the Lombok. That's where it's coming from.
Okay, that makes sense. So I think a lot of people are running into having to do that at some point, which I think I'll mention again. I also did this at some point, like 6 years ago or so, on an Android project. It's always a good time. And then the other point you made about migration is that you really want to perform as few migrations at a time as possible, right? So you don't want to change the language and every single library at the same time, or you don't want to introduce the syntax sugar immediately. You can go step by step, be safe about it, make sure that you have tests for everything and that they still run at every point. Because if you try to migrate like 3 or 4 different libraries or frameworks at a time in a project, you're going to have a really bad time trying to untangle it if something goes wrong. So really just for safety, that's a really nice approach to take. And then before we go into some more about AI, actually bridging into that, I should mention that we also had a big talk from Uber this year at KotlinConf, where they talk about migrating, I think, millions of lines from Java to Kotlin.
I've seen it. Yeah, it was very impressive.
Yeah. So did you have a lot of shared experience with what they covered in that talk in terms of converting and then how like AI can play a part?
If I'm not mistaking the talk with a different one, I think I would say no, simply because the scale of their teams and their code bases, it's a completely different level. Because they introduced a lot of automation and a lot of agentic, like self-verifying pieces. And so they built a whole pipeline to do that. And that makes sense, I believe, when you have 100 or more than 100 engineers. But for us, where the validation team I'm working in, it's like 5 engineers. So while I found it extremely impressive, we just didn't have there's no way to justify such a extreme approach. And again, also the code base is order of magnitude smaller. So definitely felt inspired, but wouldn't apply it in this case.
So then what was your approach? You said we're in a totally different place with AI. How did it manifest for you?
Yeah, let's get back to that part, because I think when I initially thought how I'm going to talk about it, I split it in three eras, let's call it. The pre-AI era, which I just discussed with the whole either manual translation or using the built-in automatic converter, non-AI converter. And then the, let's call it early AI era rolled in, which is when ChatGPT became popular and there are things popping up like Cloud Code. And then a while later, I believe, AI Assistant came into IntelliJ. So that's when we started not just as a team, not just as in the scope of the Kotlin migration, but as a whole company started to think how we're gonna leverage AI and how we can use it to our benefit. So there was definitely a lot of experimentation with the tools available. I think we started with ChatGPT, and that was the early days of it. So no agentic flows, no integration with IDE. So what it came down to, what we would do is just paste snippets from IntelliJ into ChatGPT and see how it goes.
Yep.
Sometimes it's good, sometimes it's bad. In the beginning, especially, the context size was extremely small. The input size was extremely small for these tools. So if you were to paste a big snippet, a huge class, a few hundred lines, it would just tell you, would just give out. Or a very common pattern back then was that it would print the beginning, then leave some like space in the middle, like fill the rest in, and give you the like the closing bracket at the end, and just tell you to deal with the rest yourself. So we went through that phase. So, but we seen the potential. It was very, very, very helpful. Even in the early days when the models weren't perfect, it would usually do a good job. And we would incorporate these flows, these like early primitive AI flows, into the migration pipeline that is discussed before, because you can generate with AI and then you're gonna run through the existing tests anyway. So you have the assurance that it's either correct or not. And then you can make small tweaks by hand. Sometimes they were required from the AI output, sometimes not. But it definitely helped speed things up. Even if you weren't to directly then paste the code back into it, you would at least get something that's usable to then build on top of.
And you said that this was kind of like the early-ish era of AI. All things have evolved a little bit. We have, I think, agentic workflows are becoming more and more prevalent with things like Junie and the like, also just like directly integrated into your IDE. So what's that looking like nowadays?
A little bit is an understatement. Yeah, this space definitely moved still moving extremely quick, the whole AI space. And yeah, you can talk about it if it's a bubble or not a bubble. That's not the point. I think it's proven itself to the point where we know it's usable for coding, and it definitely makes work easier. And the output is usable if you're careful about it. So I'm not sure, should we jump straight to the agentic stuff? I think there was, before even the agentic flows came in, I think there was a huge improvement, like let's call it a period of a year. The models improved drastically in terms of the output we've seen with the code generated. Also, the tools evolved where you could link, for instance, ChatGPT to directly to your IDE, and instead of copy pasting stuff back and forward, you could use that. So that helped as well. Also, you could attach context from these tools, which again helped a lot. And also the context window got bigger. The input tokens limit got bigger. So these improvements alone, even before the whole agentic thing rolled in, that was a major improvement and a major bump in terms of speed for us, how we were doing this. And then only after that, the whole agent thing rolled in, which I think is probably a year, less than a year from now. And I think the first exposure for us was through Junie. We didn't jump straight into the I think because cursor predated that, and we didn't jump into the cursor thing simply because I think it was a separate IDE, and it was, I think, mostly, I didn't try it. I'm just, from what I know, I
Yep.
think it's mostly focused on web, so better with web stuff. So we didn't go that route. But then we also obtained the JetBrains AI license, and then that's how we got AI Assistant. And that's how things, again, improved a lot for us, because it meant no longer copy pasting stuff. We can do it directly in the IDE. And then the plugin is aware of the files you have opened and all the context, and it can traverse the code tree itself. So again, huge benefits in terms of that. Because most of the time you're not just migrating an isolated data class, but you're maybe migrating some complex subsystem with like 20 injected dependencies, and then it's not a simple, translate this and you're done. But you have to evaluate and look at the whole dependency tree to make the correct decisions. And after that, Juni came around. Juni, my biggest complaint with it was that in the beginning was extremely slow. It's much better now, but it started.
We've heard this complaint in the beginning, and it's really made quite a big leap in speed since then, which we're quite excited about. But it's really like, I find it so fun, like listening to this story again, because it is really like a good position to be in, like doing this kind of migration and then being introduced to these agentic tools that go from that take you from like copy pasting a single snippet to like a thing that can, if you have an intertwined net of multiple classes, it can change a class, it can run tests, it can see if something breaks, and it has this like self-correcting cycle inside of it that's really, really useful, especially if you already have like great test coverage. So that's something, and I mean, we're also augmenting Juni, of course, with a bunch of functionality from the inspection, so that it can like also see the same things that you can see as a developer in the IDE. So we're hearing this story more and more from different folks, that it just gets people to the to a Kotlin multi-platform code base much faster, which is super, super exciting. Breaking down language barriers in the classical sense is really, really great. I also still think that we're in a place where like we said, it's a very valuable tool in the hands of a professional. Like, you still have to very much know like what it is that you want, and like what it is that you want to actually build in order to keep it maintainable.
Mhm.
Yeah.
I was going to mention something related, is that with these agentic flows right now, where they can iterate and improve on their own output, it's very tempting and very easy to let your guard down and just trust them. And that's very dangerous, I believe. So you really need to pay attention and not just delegate the work and hope for the best.
Yeah, no, like this is precisely the thing. I think it lowers the barrier for code creation, but I mean, code maintenance still falls on you. So at the end of the day, remaining vigilant about what actually makes it into like your main branch, what actually gets merged. I don't think anything has changed about that part.
But also, to summarize the whole adventure with the like code translation itself, I kind of regret we didn't start now, because if we started now, like we would save so much time. But I know it's not.
It's just like with the stock market. It's very
yeah,
easy. You just
pretty.
buy when it's low and then you sell when it's high. You just time the market. It's not a problem at all.
This is not investment advice.
It's I think out of all things, that might be like the only one that I'd be comfortably behind.
I don't want to talk to our legal team.
Okay, it's not investment advice. It's what I would do. But that's just me. No, of course. I mean, things always get better. Hopefully, at least. Like there's an overall improvement with the technology as it like matures, becomes more stable. I mean, we're also. I think we still need to touch on this in a little bit, but I don't want to do the big jump. We also mentioned that, for example, Objective-C maybe will sometimes will at some point go away out of the stack, and there's a direct Swift connection there. But I don't want to move up too fast. Martin, you still got anything on what we're on here?
I think we've covered the AI part. Do you have anything else for?
Well, not strictly about like translating Java to Kotlin, but the thing around it was that there were some bumps I probably want to mention, especially around testing. We were heavily using parameterized tests with JUnit. And the difficulty we encountered was that there's no parallel solution in common tests. So when you use Kotlin test, there was nothing you could do for parameterized tests. And sadly, there's still nothing you can do now, as far as I'm aware, except maybe for third party. You have libraries like Burst now, which wasn't what we had available when we started. So there were two things we would do to deal with that. Initially, we would unwrap these tests, as in just re-implement them as separate tests, which was not great. We were not happy about it. It's a lot of code. It's a lot of boilerplate. The test results you get is not what you would get, like, because you just iterate through a map of arguments sets. So not perfect. We improved on that by we implemented a simple KSP library to automatically generate the parameterized test implementations. So basically what I just described, we were doing manually. We implemented a KSP processor to do that automatically for us to generate these. That improved the migration a bit, because again, we had a bunch of these parameterized tests and we couldn't just, of course, get rid of them. We needed them. So that was the solution we used there.
I mean, I love that the decision was, well, we could just delete them, but probably that's not the best idea. maybe there's a better way. Yeah, I think at least the good part about the Burst library is that it is from the folks at Square Block. I don't know.
Cash App.
Cash App, exactly. Which of course are like a, should we say, a foundational building block? Actually, that's doubly that's doubly fun because they are also part of the Kotlin Foundation, so they're literally foundational building block. Anyway, what I'm trying to say is that the libraries have a very good standing and they're like well maintained. So at least there's an opportunity there. But it's very cool that you also like you dove in and you decided to like use the meta programming facilities, not all the way to compiler plugins, luckily, but with KSP. That's really cool.
I've yet to dive into Burst. I know it's a compiler plugin. I don't know yet what the implications of that are. So something I'm happy to try.
So obviously, when you this is kind of implied here, but it's a general theme. Obviously, when you move from Java to Kotlin Multiplatform, or more specifically, when you move to common code that's platform independent, all of a sudden the APIs that you can use are also constrained to those that are available everywhere, which is like the Kotlin standard library and so on. I guess J2 Objective-C had a different approach where a bunch of things like networking, I/O, and so on just were part of their SDK. What was the transition here? Like, what was the dependency story?
I think it's best to pick an example. I think you mentioned networking. So J2Objective-C re-implements HTTP URL connection. So you could just move with that if you continue with that, using that if you wanted to. But we decided, again, after doing the actual translation, like the second improvement part would be to move away from that to something more modern. And that's what we decided we're going to use OKHTTP. Initially, OKHTTP, I think now, sorry, no, I think we, no. I'm mixing things up. Sorry, we'll cut this out. We decided to use Ktor client.
Mhm.
Simply because it offers that flexibility to pick the right engine for the right platform, and the API is straightforward, and we already are using Ktor anyway on the backend. So again, in terms of unifying the technology stack across the whole code base, not just the code base, across the whole company, we already have Ktor in place. So why would we diverge again and pick something exotic for no reason? So it was the straightforward choice there to go with Ktor client. Also, yeah, for the network stuff, we do JSON, of course. So there was also pretty straightforward choice because there's a first-party solution for that. So instead of using JSON, which we use now, again, through J2Objective-C, you can use JSON directly. But now we have the option to pick Kotlin X serialization and just use that, which is first of all, a much smaller footprint in terms of, I think JSON is quite a chunky, if I'm not mistaken, dependency. And with Kotlin X serialization, it just makes much more sense and integrates into the whole stack much more seamlessly.
So obviously, like I think a lot of the things that you've described here are quite common for people who are doing a Kotlin multi-platform migration. Like it seems like pretty general. Networking, serialization, that's the kind of stuff that everybody does. But we're kind of talking about an interesting domain here, right? Like we're still talking about ticketing, ticket validation, like IC card readers, some QR code stories. Surely you also have some like more specific like dependencies that are required for that. We also talked about potentially like offline storage. Yeah. So I don't know what goes into this. I'm unfamiliar with the algorithms or the business logic, but I assume there's a cryptography specifically story in there somewhere, perhaps.
Yep. Exactly. Because we mentioned previously that some of the cards require encryption, decryption, similarly to the tickets. They're stored in some specific formats, and you need to do some cryptography on that. So that was that's a whole different sub-story to all of this, because the validation part relied initially on our own implementation of a crypto library, which has a historical reason that its existence was that even before this whole validation thing, there was an app for a Java ME application running somewhere. That was like 20 years ago.
Now we're
And
going
back then, now we're going back like before even I was writing code. And back then there was a requirement to, I think, support RSA and AES. And back then, someone at the company, I think actually one of the founders, he wrote a Java ME compatible RSA and AES implementation. So that's how it started with the whole approach to handling crypto here. And again, previously it was a requirement for Java ME, but now once time has passed and this whole validation thing came to be as a proper product, we inherited that. And the benefit was that it was portable, because it satisfied all the requirements needed to use it, all the platforms that we supported. So we were using that, but with the Kotlin migration came the need again to modernize and move to probably something more modern in crypto. And again, with crypto, you have to be careful, first of all.
You should be. You should be.
Yeah, when you're handling cards and payments, you probably should be careful. The good thing is that implementation was actually there's like a independent, I don't know from the top of my head, there's like an independent open test suite for these crypto primitive implementations, and you can get your implementation verified by an external party through running some suite of tests for the inputs and outputs. Like you would run 10,000 times your RSA across different inputs, and then that's how you know it's actually a valid implementation. So we knew that was safe and sound, and we didn't have problems with it. But again, the time has come that we probably want to have something modern. So that's how we started to look how to deal with it, and that's where our first discovery was that sadly in Kotlin Multiplatform, there's no alternative to the Java crypto stuff package to the implementations, because we would mostly we would rely on that for the Java targets, and then we would have a contract or an interface to delegate these calls on iOS to invoke either the native crypto APIs from iOS standard library, or none of them were available for the ones we needed. We were using a external third-party open source library called Embed TLS, which was written in C. So the way we would do that, we would bundle that library for iOS and then delegate whatever crypto we would need to do. We would delegate calls to that C library. So then the requirement came that we would like a modern, safe Kotlin interface on top of that. And that's how we started to work on what we called native crypto, which was a successor to this whole encrypt me library that I explained earlier.
Mm-hmm. By the way, just as a short maybe aside here for our maybe our younger audience, I'm not sure. When we're talking about Java ME, we're talking about like an embedded mobile targeting version of Java, which is maybe best known to the general consumers as like the little applications that ran on like the phones, the types of phones that we had before the iPhone came along. So like the Nokia phones, somewhere between the era of like Snake on the LCDs, but more like if you're thinking like your first like little like racing games or stuff like that on the games, probably in the late 2000s. And also looking here at the Wikipedia page, what's quite fun is that this is Java ME stands for micro edition, right? It's the micro one, but it is the second smallest Java implementation, the smallest one being Java Card, which actually is Java that you can run on like IC cards or on like SIM cards or like mobile payment gateways. So I guess I understand now how the billions and billions of devices running Java like comes to pass if my credit card runs Java.
Well, it has been 3 billion Java devices for the last decade now, right? That's what the installer says.
Yeah.
It's kind of worrying for growth, but impressive otherwise.
It's a saturated market.
Something I wanted to ask around code sharing. You mentioned that you.
Sorry, just very quickly. Were you done with the point? Because I just kind of wanted to make the point about the Java ME part.
I just wanted to bring up one challenge we had with
Please.
this whole approach, especially because I mentioned the embed TLS library, which we needed on iOS, and we needed it still to be used in our native crypto implementation. So there was this challenge: how do we use this C library in a Kotlin multi-platform artifact? I roughly knew at that time there's a thing such as C interop that you can use to invoke C code from the context of iOS and from the common context. So that's ultimately what we ended up using to make this work. So we bundle the embed TLS artifact and use it as a dependency for that native crypto library. But probably if I had to do it again, I would think twice, because C interop and the APIs around C interop, they're not straightforward. They're kind of there's a learning curve definitely to use them, and you definitely have to be careful about memory management, which when you're working with Java and Kotlin for 10 plus years, you're probably not that comfortable with. So yeah, something to pay attention to.
Yeah, that makes sense.
Yeah, I think we had this come up a few times, the requests around more crypto support. What they probably need in the feedback is like specific requests of what kind of crypto people would want supported exactly, like what kind of operations they do often and such. I no promises on like whether we'll have the bandwidth to cover this at any point in the future, but we definitely heard this a couple times.
I think if I can have an opinion on this, would be great to just have a mirroring of the Java security, Java crypto package, because that would probably make migration the simplest for people. I'm not saying the APIs should be identical, but should probably get a similar treatment like Java time got the alternative in the form of Kotlin next time, date time, sorry. Something like that. That's something how I would imagine it.
Yeah, I have no idea what it takes to delegate that on each platform, but I know that we worked with at least random number generation for all the platforms, and for UUIDs, for example, we need some stricter like cryptographic guarantees for random number generation. So we've done something in this area and in this space, and some of these things are definitely possible across platforms because again we do have like a UUID implementation. So hopefully we'll see something for crypto in the future as well. Before my next question, do you still have time? Because I think we're running to the end of our slot.
Yeah, definitely. Like at least 30 minutes.
Okay.
And I think we can talk. I don't know. I think Sebastian had an idea what to talk next.
Sorry, did you have anything specific in mind?
No. Because I think we wanted to talk also about like the future of how we see this tech stack. Because there's a story about. I think there's an architecture we want to get to with this, and that also involves compose multiplatform. So maybe if
yes,
that part we definitely still had on our list.
Okay,
let's clear out like
yeah. Let me do like one more question, and then we can go towards the future and wrap up, and like like check in what your state is now, and then talk about the future. Yeah. Okay. Drop my keyboard. It's all good. Which also means that I turned it off. Okay, here we go. Exciting times. What we also get a bunch of questions about is what kind of code can you share between the backend and the client side of your multi-platform setup? Because you already mentioned that you have synchronized on technologies in terms of using Ktor on both sides, with Ktor server and client, for example. But usually people find it really easy to find the use cases on the client side of what to share, because I mean, you do have the same code usually implemented on iOS and Android, for example, in mobile apps. But you probably have a bunch of things that are also shared between the server side and all of the different clients that you run on, whether it's the mobile SDKs, whether it's the embedded parts and the gates and such. So like, what kind of use cases do you have? Maybe people can take some inspiration of what they might share between server and client.
One thing I briefly mentioned is the helper libraries that I mentioned before with the like ticket encoding and decoding, which previously also were used on the backend because again they were Java, they were JVM, so that still continues now. Of course, with Kotlin, they're used there. But more importantly, the whole validation SDK is something we have. I said would, but probably at this point we have a requirement to run on the backend as well. And while not strictly enabled by Kotlin Multiplatform, because again it's a JVM SDK, so you can plug it in whenever you want, as long as it's running Java. But any platform-specific code that then would be needed to run this, for example, in the backend, or code that was previously present in the Java implementation, because again, that was one huge module when we started, which definitely wasn't possible back then because it was including all kinds of things that probably you wouldn't run or need to run on the backend side as well. So now once we modularize this and are able to pick and choose the components we want to go into the SDK, where there's much more flexibility to be able to run it in the near future on the backend as well, to enable, let's call it cloud ticket validation through an API, for example.
Cloud ticket validation. So that is that then meant for operators who are like bringing their own devices and then like just want to do like an API call or what's the
exactly
what's the
that's a use case. That's one of the use cases, because as you can imagine, if you run the mobile app, you would scan a QR code and that's your whole input. So why not enable this input pipeline to just be an API call and then just have it feed in your ticket data, which again is a string of characters. You would just send it to an endpoint and then get the validation result back as a response.
Okay, yeah, I mean that makes a lot of sense, honestly. So let's wrap up the story of where we're at the moment with one more question. Is there still J2 Objective C in your code base? Have you what percentage of like migration have you hit? Are you at that sweet 100% or?
We're very, very, very close. Literally now there's a probably last major merge request open to essentially, well, in practice, remove J2 Objective-C entirely from the iOS build pipeline. In practice, we still need it for a bit. Something we didn't, I think, have time to discuss, but there's a whole persistence layer which is using SQLite, and there's some legacy migrations present there that we for now didn't touch. They're implemented in Java code. And for that one little last remaining legacy bit, we will still have J2 Objective-C plugged in. But there's a migration plan to get rid of those, and that would essentially remove any trace of J2 Objective-C from the build flow.
Very quickly, what?
Sorry, go on.
Just very quickly, what's your migration plan for the SQL thing? What are you planning to move to?
Yeah, I need a bit more context to explain this properly. We were previously using SQLite for the local storage for all the embedded and the mobile apps. So naturally on iOS, you would use the native SQLite implementation. Again, on Android, you also have a native implementation, so it would delegate to that. Then as part of, once we were probably past the middle point of this whole migration, and as an effort of the second improvement pass that I mentioned, we decided to migrate to a different database backend. And for that, we picked SQLite because it has first-party support for Kotlin Multiplatform. So that was the major driver for that decision. So we successfully, yeah, good one. It happened by accident. What was I going to say? But I mentioned the legacy migrations, and they are implemented as text SQL commands in a Java code file. And for now, we didn't touch them. We still have these two entry points for the persistence layer. So we have the legacy one with plain SQLite, and we have the modern layer, let's call it, for SQLite. They can both talk to the same database, but the legacy one is only used to run the legacy migrations. So when someone has an app that's 5 years, they need an upgrade path to a newer version, so we cannot just abandon that. So we already have a plan to migrate the migrations.
as one does, yes.
Yeah. So they can be also multi-platform code or something else potentially. We're also considering just doing a one-off migration to Objective-C for them, and just because it's not code that's going to change these migrations. They're just plain SQL that you need to run. Maybe a bunch of calculations, maybe for some new key or value in a table, but that's about it. And after that's done, we're fully detach ourselves from the old stack, let's call it.
Yeah, very cool. And that's also a really nice, that's just a really beautiful engineering story of keeping that many things working over time, introducing new technologies, but also still being compatible with everything that came before. That's a super nice effort. So with that, what are you looking to do once you are done with this migration? Do you have new avenues to explore, new features that you are planning to build? Is there something new that Kotlin Multiplatform enables? You've mentioned this cloud ticketing with shared validation on the back end. I don't know how much UI you have. I guess a lot of this code is business logic, as you mentioned, but I assume in the mobile apps you do have some UI at some point. Maybe you can mix in some Compose there with Compose Multiplatform. So what's the story going forward from here?
The major thing is definitely Compose. There's a fair bit of UI in these apps. I would say, I think from the top of my head, there's like 15 view controllers, view models. So let's say 15 screens in the app. There's some settings. There's the one to scan the QR code. There's some screens to, maybe a bus driver wants to select the station or vehicle or train he's on. So there's a thing about that. The whole login flow. So it adds up to about 15 screens, give or take. And currently, the biggest thing I would like to deal with for us next is to deal with the fact that now it's implemented double, as in Android has its own implementation of this UI, and completely separately iOS has one using Objective-C, which in itself we're not happy with as a language, because the new code, if we ever need to add new code to iOS currently, we decided to do that in Swift. But the UI code still unfortunately exists in Objective-C. So probably instead of doing a rewrite of Objective-C to Swift to modernize things, we would like to jump to like get two birds with one stone and get rid of Objective-C and get rid of the duplication at the same time. And what enables that is Compose Multiplatform. So once we wrap this effort up, which should be soon, we will be looking into that.
Are you already using Compose on the Android side, or are you looking to migrate Objective-C and views and all of this at the same time to Compose Multiplatform?
Unfortunately, it's the latter. So it makes things a bit harder, because if it was Compose, it would be much easier, but we're not in that position. Probably the good thing is that these UIs, they don't really change that often, so should make the migration a bit easier. So less moving parts. I don't have a plan yet. How are we going to do that? How are we going to deal with it? We didn't do planning for that yet. So hard for me to say at this point how we're going to approach this to, like, again, enable a incremental migration with all the moving parts. But I think with the existing base, with multi-platform and everything being Kotlin, I'm optimistic about it. That shouldn't be that hard. And also I see a benefit in it that there's less room of error, because you have twice less code, and then the platforms, they run the identical code, so there's no longer the case of introducing a bug on one or have a feature diverge on one platform compared to the other one. So there's definitely these huge benefits to it.
Consistency is, I think, one of the really enormous benefits that underpin just generally the entire sharing story, right? It's the same from, well, we want to run our SDK on the back end, but we don't want to re-implement it for multiple platforms. God forbid your validation logic is different in one place than it is in another, but it extends all the way to the UI. There are still, if you have established flows and you want them to work consistently, what's better than just being able to write them once and having the assurance that they're consistent. Yeah, this is a really, really cool deep dive, and it makes me very excited to go on the train the next time, hopefully interfacing with a ticketing system built by you folks at Masabi. Are there any large cities that we should be on the lookout for, or that we should know about, so that we can be excited when we go on their trains?
From the top of my head, I'm not sure. There's one in Spain. I think it's Madrid. Could be Madrid, perhaps. You need to check on the website. I'm sure there's stuff listed there.
All right, very good. So we can just take a look at the Masabi page, and see. No, because this is really exciting. Personally, again, I'm slightly biased, but I would be very excited if my paper tickets in Munich were at some point also replaced by a solution like yours, written in Kotlin Multiplatform. That would be quite a delight. Yeah. Very good. Well, this was a lot. Very excited once again to see that in an area that touches millions of people's lives every day, that there are really good paths for getting Kotlin multi-platform introduced into legacy code bases that power these kind of things. And yeah, that it's possible to do these things. It's really awesome hearing about Kotlin just powering the modern world. I get a little bit giddy every time. So yeah, thank you very much for being on the show today, Paweł. I really do appreciate it.
Thanks for having me. It was a good conversation.
And thank you everybody who decided to tune in today. And of course, if you would like to share your opinions on public transport or Kotlin multi-platform, you can join us on the Talking Kotlin Slack channel, which is part of the Kotlin Lang Slack workspace, if I have the terminology right. You can, of course, also just write some comments if you're finding us on YouTube, or I guess you can figure out how to find any of the other channels if you're listening to an MP3 on your phone on the commute, maybe on a train. Who knows? So yeah, thank you very much. We hope to see you in a future episode, and have a lovely Kotlin. Take care, everybody. Bye bye.
Thank you. Bye.
Bye.